I recently cut all the Mali Garnets that I had, a total of 5 stones. The biggest I cut was just over a carat, and all 5 were beautiful, and I really liked the fire and the sparkle that Mali Garnet has. It was pretty awesome. Well, I searched and searched and finally found a rough dealer with 1 Mali Garnet rough stone over 6 carats in size, which is very rare. It was the only Mali Garnet he had in stock, so I understand only about 2% of facet grade Mali Garnet rough stones are larger than 6 carats in the rough. So here it is, a whopping 20.225 carat piece of uncut Mali Garnet. I have examined it as best I can, and it's difficult to see inclusions or fractures in uncut gemstones, but this one appears to be clean as a whistle. Thanks, Matt. Well, as it turns out, my all-time favorite gem cut designer, the late Jeff Graham, once created an oval design specifically for Mali Garnet. So that's the design I decided to use. Jeff was a remarkable faceter and gem cut designer. He was big-hearted enough that he gave many of his designs to the faceting community to freely obtain and use. However, other designs he published in his numerous books on gem cutting designs, and these designs are not freely available to the public. You have to purchase the book. I found the book that this design was published in. This design is in Jeff's book, Additional Designs number 8. Well, good luck finding this book on the usual websites where used books are bought and sold. I don't think you're going to find it. Jeff's books just don't end up the used bookstores, but they might. There is one supplier of lapidary equipment and supplies who sells Jeff's books. As I understand it, she does this in agreement with Jeff's estate. So there could be others. I don't know of any, but if you're looking for Jeff's books, try The Rock Peddler. The design that Jeff created and published in his book is called Birdie. Jeff's Birdie design calls for a length to width ratio of 1.250. The stone I bought is 15 by 12 by 11, which is a length to width ratio of 1.250. Perfect match. Well, not exactly perfect, as you need to know that the measurements of your rough cell and what the rough seller gives you, in this case 15 by 12 by 11, although accurate, does not mean your stone is a perfect 15 by 12 oval. It just never happens that way in the real world. Here's Jeff's design. I won't be able to share the cutting instructions with you, but if you like the design, you can pick up Jeff's book and the instructions. Jeff's notes say that he designed this cut for Mali Garnet, but that it works well in cutting any garnet. So let's see how well it works with my Mali Garnet. In this video, I also want to make an estimate of the final carat weight using the volume calculation provided in gem cutting designs and diagrams like those in facetingdiagrams.org or those that Jeff created. In a previous video, actually 2 videos, I explained almost all about gem faceting diagrams. And I'll provide a link to the 2-part video in the description. The videos were Gem Faceting Diagrams Part 1 and Part 2. In those videos, I did not explain about the volume calculation because I had never used it. However, in this case, because Mali Garnet rough in sizes larger than 5 or 6 carats is rare, I'm going to use the volume calculation Jeff provided to estimate the finished size of my stone before I even start cutting with this design. The volume calculation allows you to estimate the final carat weight of a gemstone that you're going to be cutting. In the diagrams that you can download from places like facetdiagrams.org or on Jeff's designs, the volume figure is listed as volume divided by the cubed width of the final gemstone. So by estimating how wide the stone you are cutting will be, you can estimate the final carat weight. Confusing? That's probably why I never used this calculation. So in the two-part video, I don't explain the calculation, but now I think I can. So, especially after a fellow gem cutter named Larry Shute researched the volume issue. Larry found a definition of gem volume in volume 1, page 136 of Tom Herbst's book, Amateur Gemstone Faceting. And in the book it reads, the final line of the information block gives you the ratio of the final gem volume to the cube of the width W3. As you shall see later, this information, combined with knowledge of the density of the gem material, can give you an accurate idea of the weight and hence value of the finished stone long before it is complete. Still confused? Me too. But let's give it a try and break this down step by step. The first thing we need to know is the specific gravity of the material. Although Mali Garnet is a mixture of grossular garnet and andradite, it is mostly grossular. So I'll use the specific gravity of grossular, which is 3.6 to 3.68. Andradite is 3.859. So I'll use the upper end of grossular of 3.68 in this calculation, and I'm hoping that should be close enough. Gem calculated the volume of Birdie at 0.294. That figure also gets plugged into our calculation. So if I understand correctly, the formula is volume times specific gravity times width cubed, or width times width times width. So the width of my rough is 12 millimeters right now, and let's assume I'm able to cut this stone and get a width of 10 millimeters when I'm done. I think I can do that. What would be the carat weight? So 10 cubed, or 10 times 10 times 10, is 1,000. So the volume would be 1,000 times 3.68 times 0.269, which equals a boulder. When I started with a pebble, well, either the Rock of Gibraltar or basically a wrong answer. Okay, phone a friend. Calling Australia. Reg Poirier, the creator of Gem Design Studio, to the rescue. I asked Reg what I was doing wrong with my calculation, and Reg quickly came to the rescue and figured out what I was doing wrong. First off, the width of the stone is in centimeters, not millimeters. So I have to convert from millimeters to centimeters. Second off, the final number is in grams, not carats, so I need to convert from grams to carats. So converting grams to carats, millimeters to centimeters, geez, I'm American. We use inches and feet for a reason. Okay, starting over. First, convert millimeters to centimeters. Plan to hope to cut this stone at 10 millimeters. So 10 millimeters is 1 centimeter. Now I can replug everything into the calculation. So replugging the numbers in, 3.68, the specific gravity of the stone, which you Google. 1, the width in centimeters, not millimeters. So 1 times 1 times 1, which equals 1. 1 cubed is 1. That's easy. And then the 0.294, which is provided in the diagram. So when you multiply the 3 together, you get 1.08192 grams. Now we have to convert the grams to carats. 1 gram equals 5 carats. So the 1.08192 times 5 means I should end up with 5.4096 carats. Whew. If I end up with a 10 millimeter wide stone. So that's the calculation. Confusing? Wow, yes. Probably why Reg in Gem Cut Studio, he performs the calculation for you in his software. Again, thank you, Larry Shute. Thank you, Reg. I hope I don't have to do these calculations again, like ever. For me personally, in my opinion, and I think most cutters go along with this, we have a fair estimate of the return that we're normally getting on stones. and it's around 20-25%. Sometimes on a badly preformed or badly shaped piece of rough, it may go down to 15%. You know, on a good piece, it may go up. So somewhere around there. So we kind of know, I kind of know what return I'm going to get. So my way, you know, I look at this piece of garnet. It's well shaped as an oval. It fits the design well. That's going to increase my yield, my rate of return. I'm in the 20-25% range, so I'd say maybe 30%. I don't like to be so optimistic, but let's go with that. So the stone is 20.225 carats to start with. Take 30% of that. That would be 6.0675 carats. And that's in the ballpark of the complicated volume calculation that we just went through. So maybe I'll just stick to estimating the final weight based on how much return I'm normally getting from the stone and the shape that I see it. I think it's going to save me a lot of trouble. All right, so here's our Mali Garnet, all dopped up, and it's got just about 12 millimeter width right now. And let's cut the stone and see what we end up with. All right, we're ready to cut our big piece of Mali Garnet, and the design Birdie is an oval design, and it calls for putting the stone in the dop and orienting it kind of horizontal at the 96-degree index. And what that means is for our quill, our index gear, we put our index gear to 96, and at that point we want the stone to be kind of horizontal, or it's kind of an oval shape, so we want it shaped kind of like that, put in the quill. Now this is a keyed dop, so it doesn't want to go in that way. It wants to go in one way because of the keyed dop feature, so it wants to set just like that, which is wrong for this design. But it's no problem, you just simply orient it the way you want, and then tighten the set screw, no problem. And we are ready to cut Birdie. Okay, I've put the first set of facets preforming my Mali Garnet here with a 320 grit diamond topper, just to get the kind of the oval frame set up. Now it's not quite done yet. It's going to have to be a little smaller on the sides to take care of this open spot here. And don't be afraid to use your permanent marker to mark facets, so that it helps you when you're cutting the next facet. You can see where to stop. Like when I'm cutting this facet, I knew I could very clearly, because of these black lines, see where I was at. Otherwise, sometimes it's hard to see. So sometimes the lines help. Again, it's a permanent marker. Don't use a water-based marker. So next step is the 600 grit topper. Okay, I finished pre-polishing the Mali Garnet with 3000 grit diamond on a bat lap. And next I'll use the dark side, which I've been having great luck with in polishing garnet. Now garnet polishes with aluminum oxide, not cerium oxide or any of the other oxides. It's aluminum oxide for garnet, so I'll use aluminum oxide. And again, when I bought the stone, it's advertised as clean. Well, and that's the problem. It's hard to see into the stone. But if you look, now that you've got the now that I've got a 3000 grit pre-polish, you can now see into the stone pretty well. We're going to have a clean stone, we're lucky. But down here at the bottom, you see that inclusion there? And over here, where the stone formed, this is the outer skin, you can see where that goes into the stone a little bit. Again, we're going to be okay because we have plenty of room for the crown, but if we didn't have plenty of room for the crown, this piece, this is the skin of the stone again, so if you turn it sideways, you can see how it goes into the stone when it, formed a little ways. But the girdle will only be the thickness of a 0.3, 0.5 millimeter, about the size of the thickness of a fingernail, and then we'll start cutting in. So we will miss all of that. And the other inclusion, you see it there. Look at it, it's a kind of a beautiful inclusion, but we don't want it sticking out of hitting the table of the stone. So again, fortunately, the table will come up and the crown will only go somewhere around this neighborhood, so we're going to miss all of these. But again, the lesson to always remember is, all of the rough sellers are happy to tell you the stone is eye clean. Some are very much better at it than others. Matthew is really good at it, but none of them are perfect. It's hard to see into a stone. So when you receive a stone, look at it, examine it as best you can under different light, take all the time you can. And if it's not clean, send it back. Send it back. In this case, I'd agree this stone was eye clean, but couldn't possibly have seen those, but I just want to point out they are there. They won't affect us. But check your stones. Okay, I finished polishing the Pavilion, or the bottom half of the Mali Garnet, and it has the same effect as the other Mali Garnets, the smaller ones that I faceted in a previous video. You can see it. It's a kind of red, orange, green prism effect right there. Even the camera's picking that up. I don't know why. It seems to be, it occurred with the other Mali Garnets too. I don't know. It's Mali Garnets just have the sparkle and brilliance of a diamond, and maybe that has something to do with it. But I finished polishing the bottom half of our Mali Garnet. Now I'll put it in the transfer jig, transfer it, and we'll be ready to cut the top half of our Mali Garnet. Okay, for our Mali Garnet, we've transferred the stone to the dot to the Pavilion so we can cut the crown, or the upper half of the stone. Now, to make sure your stone's back in alignment, you look at your diagram, and in this case, the diagram at the oval end, the widest part being horizontal, with the 96th tooth of your index gear, you want that girdle facet to be flush with a level surface. I've pre-polished the Mali Garnet with 1200 grit topper lap, and I could probably go to polish right now with the dark side lap and aluminum oxide. I believe, based on the other Mali Garnets that I previously cut, that I could do that without much problem, but there's no major scratches from the 1200. There's no major issues. Things are lined up. The meats are very, very close, so probably could go straight to polish, not having any issues. But I believe I'll just follow what I normally do and use a 3000 grit diamond on a bat lap to get a really good pre-polish, get those facets lined up exactly where I want them, and then I'll polish. Again, the easiest, best way, in my experience, to get a good polish is spend the time on the pre-polish. So I'll use the bat lap. Finished polishing our Mali Garnet, and I'll put it in some acetone and soak it overnight, and should pop off the top, and we'll look at it tomorrow. So the final width is 9.9 millimeters. So how good was our volume calculation? Well, if I plugged in 0.99 instead of the 10 millimeters and cubed it into our original calculation, would have come up with 5.248 carats. So not perfect. And I suspect it's because of the range of the specific gravity from Mali Garnet. It varies widely, as we talked about earlier, but it's ballpark close. So I think, for me, my simple estimating technique of just using the normal percent return on a recent stone that I've cut, or considering the shape of the stone compared to the diagram, I think I'll just use that method. I got a little bit closer than the scientific volume indicator, so I think I'll use that. So in this video, I've covered the volume calculation that is shown in gem cutting diagrams. Key points you need to know about this calculation are that you need to Google the specific gravity of the material you're cutting. You need to convert the expected width of the stone from millimeters to centimeters before you cube it, which is just multiply it by itself 3 times. And you need to convert the final answer from grams back to carats by multiplying by 5. After that, you've got your volume calculation. Happy faceting, everyone.